Okay, so I'd like to look at something reasonably violent. We've got a meteor, let's say. It's going to crash into the Gulf of Mexico, moving at 1 kilometer per second, which is really fast. Let's say it's a 300 or 3,000 kilogram, about one, I think that's 3 metric tons of big hot iron hitting the Earth. On impact, it's going to heat up, right? And we want to figure out how much that heats up. The first thing we have to think about here is the mass of this. So remember we had delta E is equal to mc delta T. We're going to look up that C. And we just have to look at that C for iron. That ends up being about 0.45 joules per gram per degree C. Completely reasonable thing. I mean, we could figure that out as far as kilograms if we wanted to. It would be probably 450 joules per kilogram per degree C. So I want to see how much the Earth heats up. In degrees C, that'll be fine. You can more or less double it if you want. Fahrenheit, it's 9 over times 9 divided by 5. We don't really care that much about it. So we're going to look at that in terms of the kinetic energy. This is the change in the energy, how much work is done. That's 1/2 mv squared. We do have something nice happening here, which is the masses cancel. So the amount of energy in that meteor is proportional to the iron, and the amount of energy change after it hits is proportional to the amount of iron, or the amount of heating is proportional to the iron. So we don't care too much about that. So we can get rid of how much iron is there, and we can just look at CV delta T is equal to V squared over 2. Right? And we said this was 450 joules per kilogram per degree C. Delta T is equal to V squared, which is 1 kilometer, or 1,000 meters per second, squared all over 2. Okay, so delta T is going to be this thing, which is 1,000 squared is 1 million. 1 million meters squared per second squared over 2 times 450 joules, which is a kilogram meter squared per second squared, divided by kilograms divided by degree C. Okay, so I can get rid of these and get rid of those, so I can cancel out most of those units except for the degree C. So I end up with 1 million degrees C over 900, 2 times 450, which is almost 1,000. So that's like 10 over 9 times 1,000. Okay, and I know 10 over 9, that's 11, so it's 1.1, so we have 1,111 degrees C is the temperature change. So that's a huge amount of energy, right? That's a huge temperature change from just being hit by a meteor. So my advice to you is, if you want to go out this weekend, avoid being hit by a meteor. All right. So that's all we need for today. I'll talk to you in class, and then we'll have some more fun later on. Bye now.